K means clustering. Okay, let's discuss how K means clustering works. This is one of the most simplest algorithms in the ML, overall algorithms that we have in ML. So let's see how it works. First of all, what is clustering? Clustering is basically um, when we are trying to group similar things, right, into a cluster. That is basically clustering. And in the full K means clustering is a ML algorithm. It is an ML algorithm which is unsupervised. Okay, that is, it doesn't have any predefined labels. So, since it is an unsupervised algorithm, it doesn't have any predefined labels. So, what we are trying to basically do is we are trying to find uh, s- uh, similarity in the data and form patterns upon that, right? For example, let's take this as 1, this as 2. I'll be performing the full calculation as well in this video. 1, 2, 3, 4, 5. Right? And if I say, okay, there is a point that lies here, there is a point that lies here, there is a point lies here, there is a point lies here. Okay, there is a point that lies here, 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 and here. So this is a cluster, this is a cluster, and this is a cluster. Okay. Now we can see this visually, but the algorithm doesn't have eyes, right? So we need any mathematical intuition behind it to make these clusters. So what can we do to make these? So let's discuss first how these clusters are formed and what is the math behind it. Okay. So there is a concept of centroids. Centroids is nothing but it is the centermost point. That's it. That is the concept. No, I'll tell you more. But a centroid is centroids are basically centermost points, right? Just keep that in mind because that will be helpful in understanding k-means clustering. Now, what we do when we try to form these cluster, okay? I'll just remove this. For example, we don't know what are the clusters and we are trying to find patterns in the overall graph, whatever. First of all, what we will do is we will initialize the value of k. Now, what is this value of k? I didn't tell you, right? The value of k is the number of clusters that you want. Yes, number of clusters you want. Now, what does algorithm? Sorry. Okay. Now, what is the use of this algorithm when we are giving the number of clusters? In the beginning, when we are trying to learn something, we do not directly jump to the advanced topics, right? So there is a topic in which we can know what is the optimal value of k um for a particular data set. But in the beginning, let's take an assumption that we are setting the value of k, okay, initially, and we are setting this value of k as 3 in this case. Now, number two is we have to um, initialize k centroids as well, meaning that we will initialize three centroid points. Three centroid. After that, what we will do is um, we'll use the Euclidean distance. Euclidean distance. I hope, sorry, I hope you know that Euclidean distance is the formula to calculate the distance between 2 points. and it's very simple. In a two-dimensional space, it is this x2 minus x1 whole square plus y2 minus 1 whole square. That is very basic. I know that is not very difficult to understand. This is just the coordinates. We are subtracting them parallelly, and then we are summing them and taking the under root of that. And we will do that for every point with the centroid, with the centroid points. Okay. And then after that, what we will do is we will so after this we will do um yeah, after this we will form clusters. Now how will clusters get formed? When the centroids that we have taken and the distance between points, whichever is lesser, right? So I'll take an example. Like for example, we took this point as centroid, we took this point as centroid, and we took this point as centroid. Okay, in the beginning, because we can initialize k centroids, which can be any point, right? Okay. So now what we will do is we will try to calculate distance of this centroid from each and every point. Okay, so we will calculate the distance between this, 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 right? Okay. So you get the point what I'm trying to make here, okay? We just calculate the distance of the centroid. Let me just, yeah, yeah. So we just calculate the distance of the centroid and the points. And whichever point um, the centroid is closest to, or let me put it this way, the distance between the point and centroid, we will calculate that, and that number for particular centroid will come. So there will be a point for this, sorry, there will be a value for this from this point to this centroid. Now from this point to this centroid, and from this point to this centroid, right? And whichever is the least, we will classify that point to that centroid. Okay, so this point belongs to this centroid because the distance between these two is the minimum. The maximum distance of this point from the centroid is this, and medium distance would be this, right? Similarly, when we calculate for this point, we'll calculate distance from this centroid, and this centroid, and the least distance is this, so it will get classified to that centroid. That centroid's cluster basically. So the cluster will get formed on the basis of the distance, and the distance between the point and each cluster will get calculated with the help of Euclidean distance, and then we'll form the cluster based upon that. So this is how clusters are formed, and then we'll calculate the mean of the cluster, the new clusters. Now we'll calculate the mean of this cluster, mean of this cluster, mean of this cluster to check whether we have correctly classified the points or not. And then what basically happens is when we are trying to take the mean of the new clusters, it will um, do this clustering. Okay, so after it has made clusters, and we have calculated the mean of the new cluster, we will update our new centroids. So whatever is the mean will be the new centroid, and then again we will calculate the distance between the new centroid, right? We'll calculate the distance between new centroid point, sorry, the new centroid point, yeah, the new centroid and the points again, and then we'll again classify centroids based upon that, and then we will do the same until and unless our uh, mean from the last centroids, mean of the last centroid, which is actually the centroid itself, and the current centroid is same. That means no no more clustering has taken place, and we have reached our final answer of clusters that we have made. So this is how the k-means clustering works. Now let's try to make this. Okay, let's try to do that. Let's say that we chose ks3. Okay, we will initialize the centroids now. Let's take any random points. Let's take let's take this as centroids. Now you are saying, you might be thinking that why I have taken these points. We can take any point to begin with, because anyways when we form the clusters it will get updated as centroids is the we'll take the mean basically, right? So if I wanted to plot it 1, 1.5, and let's take it as 2, this point. Okay, because these are my centroids. So my centroids are, on the axis it's y, sorry, 1, and on the x let's take this point as, sorry, on the y let's take this point as 2, this also as 2, and this as 2.5. So 1 comma 2, then we have 1.5, this is 1.5 comma 2.5, and then we have 2 comma 1.5. So these are our centroids in the initial phase when we are trying to begin with our clustering. Okay, and now what we will do is we will try to make clusters based on these points that we have. So we will calculate the distance of each point with each of these clusters, and whichever is minimum we will classify that point to that particular cluster. Okay, so first point is this points cluster from this and this, right? So let's see, let's say it is 1, on the x it's 1. Okay, on the x this was 1.5, and I took it as 1, right? Sorry, okay, this is 1.5 on the x-axis, and the y-axis it's 1. So what we will do is we will try to just calculate the distance between these three and take the under root of that. 1.5 and 1 here. Okay, so we'll do basic math, which is this: 1.5 1.5 minus 1 whole square plus 1 minus 2 whole square. Okay, and then next 1.5 minus 1.5 whole square plus 1.5, basically is this, minus 1.5, and 1 minus 2.5 whole square. And the last one is 1.5 minus 2 whole square plus 1 minus 1.5 whole square. So we will calculate these three, and now we will classify the cluster based upon the um, least distance of the point with the centroid. So 1.5 minus 1 is zero point 0.5 whole square. So zero point 0.5 whole square I think is 0.5 into 0.5, 2.25. 1 minus 2 is 1, 1 whole square is 1, and then we'll do the under root of that. So that will be under root of 1.25. 1.5 minus 1.5 is 0. 1.5, sorry, 1 minus 2.5 is 1.5 whole square, and that would be, I think, any number 1.5 whole square. I'm just getting rid of the negative because it doesn't matter, because we are going to take the square as and here we have 1.5 minus 2, which is 0.5, right? 1 minus 1.5 minus 2 is 0.5. It's the negative, but I'm not taking the negative term. 1 minus 1.5 is again 0.5. So 0.5 and 0.5. So this will be 0.5, 0.5 is 1. Sorry, 0.1. We'll have 0.1 whole square, right? Now, 1.5 square, if I'll try to take that, it's 1.5, 1.5, basically 15, 15, and 15, 5, 5 are 20, 5, 5 are 25, 5 are 5, 6, 7, 1, 5 are 5, 1, 1 are 1, 5, 7, 3, 225, I think, right? Yeah, so that's under root of 2.25, and this is basically 0.1 whole square, so it's 0.01. So I think this is the least distance, right? We can clearly see as well. So let's assign this point to that centroid, okay? Because the distance is least. So this point belongs to this centroid, sorry, this cluster. Now similarly we will do this for this same calculation. Now I'm thinking that this point, visually I'm just saying to you guys that this point will not belong to this one cluster, so we are not taking the mathematical formulation for that. We'll just calculate with this and this, okay? To reduce our maths basically. So this is, what did I take this? This is 2 and 1.5. And this point, let's take it as on the x and on the y, 2 point, sorry, on the x let's take it as 2.5, and on the y axis let's take it as 4 maybe. This is 4.5. Yeah, let's take it as 4. And we have this point 1 and 2.5, and we have 2 and 1.5, because this is very far, so this won't be the optimal distance or the least distance. So we'll take 2.5 minus 1.5 whole square plus 4 minus 2.5 whole square. Similarly, we will take 2.5 minus 2 whole square plus 4 minus 1.5 whole square. Now 2.5 minus 1.5 is 1, and 4 minus 2.5 is 1.5, right? And 1 square is 1, 1.5 we just calculated it, it is 2.25. So it's around 3.25. And 2.5 minus 2 is 0.5 whole square plus 4 minus 1.5 is 2.5 and whole square of that. So 4 minus 2.5, yeah, 25 plus 15 is 40, so like that. 2.5 is 6.25, I think, 25 into 25, and 0.5's whole square is 0.25, and we'll take the summation of that. 0.25 plus 6.25 is, I think, 6.5, under root of 6.5. And this, so this is clearly the point, right? Because it is lesser. So what was this point? It is this one, which is x 1.5, and on the y it's 2.5, which is this. Yeah, and we can clearly formulate also why it is so, because yeah, it is actually very less. Yeah, so it's that. And similarly, I'm not gonna calculate for each and every point, but you can do it. I'm just gonna do the update, which was the calculating the mean basically. So I will form the centroids, like this point will not have anything here, but it's okay. Initially we are trying to do that, so let me just quickly do it, okay? So this point was belonging to this point belongs to, let's use some other color. Let's use pink for pink for this one. Okay, so it belongs to this. For this one it's this initially, okay? Then if this point, which is nearest to this in this whole cluster, belongs to this only, then all the other point will belongs to this cluster only. You're getting my point? Like this. And similarly for, I think, all these points, this will be the cluster which it will belong to. based on the same intuition, and this will be alone. There is nothing initially for it. So next step is to calculate the mean, right? So we'll calculate the mean of new formed clusters. So we'll calculate the mean of this, mean of this, and mean of this, right? And this mean will be our new centroid. This is how it will work. So if I try to calculate the mean, it's what is the mean? It's basically the summation of everything, summation of everything divided by the number of points, right? So when we'll do that, um, we will have new centroid points. Okay, so I'll remove this. For example, our new centroid came here to be like this. Okay, for this it came out to be here, for it to be here, and this is the new centroid point still, because this is the same as it was earlier as well, right? So again, what we will do is, now this centroid point, we'll calculate the distance from each point to this centroid, from distance from each point to this centroid, and distance from each point to this centroid. So now this time this cluster will get formed. This cluster will get formed. Maybe this, yeah, and this cluster will get formed. You're getting why? Because we'll do the same, and then again we'll calculate the summation of everything divided by the number of points. So we'll get new centroid. So our new centroid will come over here somewhere. It will get shifted. Our new centroid will come over here somewhere, and our new centroid will come over here somewhere. So again, we will see the distance of each point to this centroid, and then again we'll form the new clusters, and then we'll do this until this centroid movements get 0. Basically, the last centroid was equal to the current centroid, and in doing so we will get our final cluster, which is this only, if you can see, right? So this is how k-means clustering works. I think there is nothing else to discuss anymore. Yeah, there is one more thing, which is how you decide the optimal k, which I will cover in the next video maybe. And yeah, that's pretty much it. So that was it. Thank you.